Hello there. This video will help you complete your second Excel assignment and will also show you how to compute a t-test for single samples and a t-test for related samples in Microsoft Excel. In addition to showing you how to do this in Excel, I'm going to go through and explain what all the values in the outputs actually tell you. And in addition to helping you complete this assignment, that information should also help you do better on your quiz. So once again, we're going to do an assignment where you're going to be recreating a results section from a real-world study published in a real-world journal article that's peer-reviewed. So this study is really looking at the impact of familiar lullabies on social affiliation of infants. And of course, you can't ask an infant if they feel social affiliation, so they operationalize or measure social affiliation by seeing how long they stare at a particular individual. So if we go, and you can read this on your own in the assignment, it really gives you the rundown of the study. But let's go ahead and focus our attention quickly on the methods section of this actual article that I encourage you to read. At least read experiment 1 because that is the one that we are going to be focusing on. There's actually 5 experiments in this study. So if you go down here, and I highlighted the most important pieces of information, if we look at the method, so parents were brought to a lab and they were instructed to sing a specific lullaby to their baby for 1 to 2 weeks. And this is a lullaby that the baby had never heard before, and the parents were given specific instructions on how to sing it. They were given a video to watch to help them learn how to sing it. And if you read more into the method, you'll see that there was controls to make sure that the parents were singing it appropriately. Then after that 1 to 2 week period where the parents were singing the lullaby to the children, the babies were brought back to the lab and they looked at the attention for 2 individuals they had never seen before. And you can see that they have kind of a picture of what those individuals looked like up here. So for the baseline trial, they just had the infants stare at a screen that had 2 pictures of individuals smiling at them, and a researcher recorded how long they stared at either person. Then they had the familiarization phase of the task, where the individual or the babies would see one of the people that they just saw singing the familiar lullaby, and then the other individual that they just saw in the baseline period singing an unfamiliar lullaby. Then they recreated the baseline again, where nobody was singing, but they just had the 2 women up on the screen, and they recorded how long the babies stared at which individual. And really the hypothesis was that, remember, they're thinking that familiar lullabies are going to result in social affiliation, which means they're going to stare at that person longer, that the person that they saw singing that familiar lullaby was going to get more of their attention in the test phase. So what we're going to do is we're going to use Microsoft Excel to recreate all these analyses that are presented right here. And really the first 2 are just kind of like a check to make sure that the infants were in fact, not showing a preference at the onset of the study. And then the final 2 analyses will be seeing if they actually paid more attention to the individual that sang the familiar lullaby after they heard the familiar lullaby. So let's jump right into the assignment. So the first thing that we want to look at is showing that the infant's looking behavior did not differ from chance during the baseline trial. So in other words, we want to make sure that they didn't stare at the person who was eventually going to sing that familiar lullaby more than you would expect just due to chance, or more than 50% of the time. So that's where that 0.5 comes from that we're going to insert into the data. So in this case, the null hypothesis, which is always that there is no effect, is that they're looking at that person equal to chance, right? So they didn't show a preference. The alternative hypothesis here is that there is an effect, or there is a difference, that they are looking at that person that's eventually going to sing that familiar lullaby more than you would expect, or a differently amount than you would expect due to chance. So as you can see here, different, significantly different, that's a 2-tailed test, and that's what it's reflected in these hypotheses right here. No, you're not going to have to recreate these. I have them here for you. That's why there's no points allocated to it. So what we're going to do is we're going to run a single sample t-test in Excel comparing the proportion of time they stared at the person who's eventually going to sing the lullaby during the baseline period before they actually saw the lullaby to chance. Let's go ahead and hop into your Excel worksheet. And we are really going to be looking at this baseline value right here. And before we do that, we're going to need to add, so right-click, insert, and we're going to put chance in here. And remember, chance is 50% of the time. So 0.5. Now instead of going 0.5, 0.5 all the way down, you should be able to click on the first 0.5, look for the box at the bottom right side, the little square here, wait till you see the plus sign, click and drag down for all 32 cases in the data set, and it just copies that value down. Now, before we can do a t-test or any hypothesis testing in Microsoft Excel, you first have to activate the Data Analysis Tool Pack. Now, I already have it activated, but you probably don't, so I'm going to show you how to do that right now. So you click on the File tab in Excel, go down to Options, then you want to click Add-ins, and you're going to look for Analysis Tool Pack. So once you click that, you're going to go down here and click Go. Make sure Analysis Tool Pack is selected, little checkbox, and then you're going to click OK. Now once you do that, when you click on the Data tab up here at the top of your screen, you should see the Data Analysis option appear right there for you. So now that we have that option, we can run a single sample t-test in Excel. So let's go ahead and do it. So we click Data Analysis. And there's tons of options here, but we're going to go down to the bottom. And we're going to do a t-test to sample assuming equal variances, or unequal variances, this one right here. So it's important to note that Excel really doesn't have a specific option for a single sample t-test. We are basically creating an independent samples t-test that you'll learn about in a future chapter, but we are just using chance as a constant value. And that's really reflected as like if we were testing it against a population mean, then that would be what we would put here for the chance value that we're about to use. But we're not really testing this against a population mean. We're testing it against a predetermined value, which is 0.5, which is chance. So again, we're going to kind of hack Excel to do a single sample t-test by using the t-test to sample assuming unequal variances analysis. So you click OK. Now you'll see this box comes up that says variable 1 and variable 2. I typically make variable 1 the sample, so that's this. And then variable 2 would be your population, or in this case, a predetermined value, which is chance. So you'll click that box next to variable 2 range, then you'll just highlight the word chance and all of the numbers. So notice earlier, I highlighted the label and the values. So you want to click this box that says labels right here, so that Excel knows that that first row that you highlighted includes the label, not an actual numeric value for data. Don't do anything with this hypothesized mean difference. You can leave your alpha at 0.05 because if you look in the assignment, that's the alpha level that I provided to you. And then you want to label a new worksheet. And let's go ahead and call this baseline versus chance. So you'll see when we click OK, a new tab is going to appear at the bottom that has the output for this analysis. So let's go ahead and click OK. And there it is. Now you can see this is kind of scrunched up and hard to see. I'm going to go ahead and go right between A and B up here. See that double-sided arrow? Double click. Right between B and C right here. Double click. And then right between C and D right here and double click. That just auto fits it to the width of that particular column. Okay, so let's take a look at this. You'll see in the assignment that I'm going to ask you what is the value for the t statistic or t observed in the sample, and I'm going to have you explain what that tells me in plain English. Luckily, I'm pretty much going to give you the answer in the video. You just have to listen and write it down. Then I'm going to ask you what is the critical value for the t-test or t-crit. I'm going to ask you what is the p-value for this test and explain what that tells you in plain English, and we'll get to that in a second. Then I'm going to show you how to determine what decision the researcher should make. Should we reject this null and say there is a difference from chance? Or should we fail to reject the null and say that, the babies really didn't look at that person more than you would expect to see just due to chance? And you're going to make that decision based on looking at your t statistic compared to your t crit, but you could also make that decision just looking at the p-value. But I'll walk you through it. So let's go back to our output, our baseline versus chance output, and let's talk about what these values are. And I'm going to see if I can zoom in on this a little bit. There we go. Okay. So here you've got your baseline, how long they looked at the person who's eventually going to sing that lullaby, and then you've got chance. Here's the mean proportion of time that they looked at that person, and then here's the variance. If you want to get the standard deviation, which you'll see reported in the journal article, you can just take the square root of the variance by going equals SQ, and you'll see squirt, right? SQRT, just double click that. Then click the actual value for the variance and hit enter. That's the standard deviation. There's 32 observations. That's our sample size. There were 32 babies in this study. The degrees of freedom is equal to n minus 1, so 32 minus 1 is 31. And then you see all these values here. So the t-stat is the t observed. If you would have computed t on your own, this is what you would have got in step 3 of your hypothesis test. This is the actual value for t in your sample. Now you'll see here we have a p and a t critical for a one-tailed test and a p and a t critical for a two-tailed test. All the tests that I'm going to show you are a two-tailed test, but if you had a one-tailed test, this is where you would be focusing your attention. So let's go ahead and talk about what the t statistic tells you before we jump into p versus t critical. So what this t statistic tells you, if you think about the formula for t, right? The numerator is the actual difference between means, so it'd be this minus this, and then your denominator is your standard error, or the difference you would expect to see between the baseline and just random chance, due to random chance, if it was just a fluke. So what this t statistic tells you is that the actual difference between how long the infant stared at the singer at baseline and how long they would have stared at them due to random chance, that difference is 0.674 times larger than the difference you would expect to see no matter what, just due to chance, even if that singer had no effect on how long they looked at the screen. That's what this tells you. Now, that's not very impressive, right? That's not a big difference. And you can kind of see that here, right? It's a small difference, and it's also small compared to the difference you'd expect to see just due to chance. Now, I'm going to focus my attention on the two-tailed p-value and the two-tailed t-critical. So this two-tailed, this p-value, this tells you the actual probability that you would have gotten this result due to random chance. So what this tells you is if you turn this probability into percentage, there's a 50.5% chance that you would have gotten this result just due to sampling error, just due to random chance, even if the singer had no effect on their gaze. It's a pretty high likelihood. And the reason that this is important is because what you do when you're trying to figure out what decision to make in a hypothesis test is you're going to compare your p-value to your alpha level. So if your alpha level is 0.05, then you're basically willing to reject the null. You're willing to say there's a significant difference if this p-value is less than that, right? So there's a saying, remember the null hypothesis, HO, ho, right? So if the p is low, reject the ho. So if your p-value is less than your alpha level, then you can reject the null hypothesis and conclude that there is a significant difference. But in this case, our p-value of 0.505 is greater than the alpha level, so we would fail to reject the null. So that's going to help you answer that last part of the question. One of the ways that we know what decision to make, fail to reject the null, is that this p-value, this probability of type 1 error, or this probability that results are just due to some random fluke, is really high. It's higher than the probability that we're willing to accept. So in short, if your p-value is greater than your alpha level, you fail to reject the null. If your p-value, your probability that results are due to random chance, is less than your alpha level, then you reject the null hypothesis. Now let's take a look at t-crit right here. This is a more familiar thing that you're used to working with when you do calculations manually. When you do calculations manually, you don't actually get p, you just know that when you draw your normal distribution, in this case, we're doing a two-tailed test, so that 0.05 is split in half, right? So we've got 0.025 in this tail, 0.025 in this tail. All we know when we do it by hand is that if we get a t-statistic that falls in the critical region, that the p-value is at least, or at most, 0.05. But here we actually know the p-value. So let me finish this sketch, right? Now we know what t-crit is. And if you looked this up in the t-table, you would be able to confirm it. But on the right side of the distribution, right, here's our t-values here. This would be a t of 2.0395. And then over here, negative 2.0395, right? That's your critical value. And as you can see, and I'll do this in red, our actual t-statistic, it doesn't quite make it, right? It's way too close to the middle. It's not in the critical region. So again, you know that we would fail to reject the null. We would say there is not a difference between chance and how long they stared at the singer at baseline for two reasons. Because your p-value of 0.505 is greater than your alpha level of 0.05, and your t-critical, your t-stat right here of 0.674 doesn't exceed the t-critical of 2.0395. So now let's go ahead and go back to the journal article to just confirm that we did this correctly. So if we look here, the results that you see at the top of page 489 are comparing the baseline to chance. So the proportion of time that they looked towards the person who sang the familiar song did not differ from chance. The mean is 0.521, 0.521. The standard deviation is 0.177. Remember, the square root of the variance gave it that standard deviation. The t, and then this parentheses 31, that's your degrees of freedom. So t, remember, degrees of freedom was 31. Oop. 0.67 was our t observed with a p of 0.51. 0.67, 0.51. You just recreated a results section. Awesome. So now we're going to move on to the next analysis that you see here, where we are going to compare, during that familiarization phase, how long they stared at the person singing the familiar song versus how long they stared at the person singing the unfamiliar song to see if there's a significant difference in how long they looked at those people. So what we're going to do now is a paired samples t-test, or in other words, a related samples t-test, because if you look at this data, let's go back to the data. So here's your output, right? You're going to have to go back to the data in another tab. Each one of these rows represents a different infant. So this is infant 101, that's their ID, how long they stared, the proportion they stared to the familiar person, and then how long they stared at the unfamiliar person. Now, admittedly, this is the data that was provided through OpenStats Lab, and these don't look like proportions, but the results came out good for the t-test. But as you'll see, the mean and standard deviation aren't the same. I'm not really sure what happened there, but we're going to work with what we have. Also, if you're looking at the data and you forget what these things mean, you can highlight right here. You can just put your little cursor over it, and you're going to get a little comment that tells you exactly what was being looked at. Okay, so now we are going to do a paired samples t-test comparing how long they looked at the person singing the familiar song to how long they looked at the person singing the unfamiliar song. So we go to data analysis. Now we're going to select t-test paired to sample for means. Now again, to get to that data analysis option, you have to make sure that data is selected up here at the top, and then you'll see data analysis right here. So we're going to do t-test paired to sample for means. Click OK. Variable 1, let's go ahead and highlight the familiarization phase, gaze to familiar, starting with the label, and go all the way down to the last person. Then for variable 2, we're going to do the unfamiliar. There we go. We're going to click labels so that, again, Excel knows that the first thing we highlighted was the label for each column. Then our new worksheet, let's go ahead and call it familiar versus unfamiliar. Then you just go ahead and click OK. Alpha 0.05 is fine because that's the one that I gave you in the assignment. So now you get an output for this. Again, go between A and B, double-click the double-sided arrow, go between B and C, double-click that double-sided arrow, go between C and D, and double-click that double-sided arrow to stretch that out so that it fits all the contents. So now let's take a look at this. This was the mean gaze time for the person singing the familiar lullaby, and this was the mean or the average gaze time that the infants looked at the person singing the unfamiliar lullaby. Here's your variances. If you took the square root of those, you would get the standard deviations for each. And then if we look at this, the number of observations was 32. That's our sample size. This is the correlation, but we're not there yet. Here's your degrees of freedom. And then here is your T statistic, the actual T observed. And because I didn't show you how to do this already, and I'm going to ask you to do it in the assignment, I'm going to show you how to copy and paste this. So let's go back to the baseline. You just highlight this. You can hit Control-C to copy, or you can right-click and select copy. And then you're going to want to paste that right here, either Control-V to paste or right-click and paste. So you want to make sure that you have that in your assignment. Okay. But we're back to here. So just real quick, I'll just copy it. Control-C. And make sure you're pasting that in your assignment. Just didn't want you to forget that. Okay, so now let's talk about these values so that you can complete the assignment. Again, I'm going to give you the answers. You just have to write them down. So if we look at this, first let's explain T. This is the T observed. This is your T statistic. So this is what you would have got in step 3 if you did your computations. This tells you that the actual difference in how long infants stared at the familiar versus the person singing the familiar lullaby versus the person singing the unfamiliar lullaby. So the actual difference in how long infants stared at the familiar lullaby versus the unfamiliar lullaby. The actual difference is 0.282 times larger than the difference you'd expect to see just due to random chance. Not very impressive. So it makes sense that once you get down to look at your two-tailed P and your two-tailed T, they're not impressive either. So remember, the p-value here tells you, if we turn this into a percentage, so it'd be what, like about 78% chance that this mean difference is due to random chance. It's just due to sampling error. It's just a fluke. It's not a true difference. There's a 77 or 78% chance of that. With our alpha level of 0.05, we're only willing to reject the null and say there's a significant difference if there's only a 5% or less chance of that happening. Here, there's a 78% chance that this result is due to sampling error. So that's one reason that we know that we are going to fail to reject the null hypothesis. There is not a significant difference between these two. So if we draw out our picture, again, two-tailed test, so that alpha level is split into two tails, 0.0205 here, 0.025 here. This is saying that our result falls in the extreme 78% of the distribution. That is not the extreme 2.5% here or 2.5% here. So again, that tells us to fail to reject the null, not a significant difference. Now, if we look at the t-critical, we can finish this picture. So the t-critical on the right side would be 2.04 if we're going to round, and on the left side, the negative side, 2.04. And you can see that this t-stat of 0.282 is like here-ish, right? Nowhere near the critical region. So not only do you know that you don't have a significant difference because your p of 0.78 is greater than your alpha of 0.05, but you also know this because your t statistic in step 3, if you did it by hand right here, does not exceed T-crit. Let's go ahead and put in our numbers here. So Tstat is 0.282 and T-crit 2.04. So that's how you know that you would fail to reject the null. There is no significant difference here. Now let's just go to the article to confirm this. So we go here, we say OK. So now we did our paired t-test. Remember I told you the mean and standard deviation came out funky because I don't know why those scores look the way they do. I actually emailed the person who made this to data to ask them. But we can confirm that the t-test was done correctly. If we check it out, t is 0.28, p is 0.78, 0.28, and 0.78 right here. Awesome. You just recreated that. Now we are going to do the next analysis, and let's look at our assignment. Again, I gave you all these answers so that you can put them in there. Okay, number 3. Now we're going to do a single sample or one sample t-test to compare how long they looked at the person on the screen who wasn't singing, but after they sang, right? So remember, they showed them both, looked how long they looked at the person who was going to sing the lullaby. Then they showed one person singing the lullaby, another person not singing the lullaby. Now this test is where they showed the same thing they showed at baseline. They showed the same 2 people up at the same time, but they're looking to see if the infant stared at the person who had just sang the familiar lullaby more than you would, or a different amount than you would expect to see just due to chance. Significantly different. Again, two-tailed test. So let's see if they stared at that person who wasn't singing anymore, but they stared at the person who sang the familiar lullaby longer than what you would expect to see due to chance, or in other words, 50% of the time. So you're going to go to Excel. Go back to the data, the Excel Assignment 2 tab. And now we're going to be comparing the test phase to chance using a single sample t-test hack in Excel. So you click Data Analysis. Remember, you have to have the Data tab selected to get to Data Analysis. Then you go to t-test to sample assuming unequal variances. Click OK. My variable 1 is going to be my test proportion gaze to singers. Just highlight that. Then my variable 2 range is going to be that chance variable that we created. So just 50% all the way down. There we go. Then make sure labels is selected. Alpha is 0.05. And we're going to call this new worksheet Test versus Chance. And click OK. Again, double click between A and B. Double click between B and C. Double click between C and D to make sure that your columns fit the contents. So now if we look at this, we can see that our mean proportion of time they looked at the singer versus the person who didn't sing to them was 0.593. If we look at the article, you're going to see that right there. Bam. Standard deviation, 0.179. Well, remember, standard deviation is the square root of the variance. So equals squirt, SQ, double click, squirt, the variance. And there's that 0.178. Or rounded up to 0.179 that you see in the article. Now we go back to here. Again, 32 infants, degrees of freedom, and -1 equals 31. Let's make this a little bigger. Here is our T statistic. Now we're getting a bigger number. This tells me, this T-stat, this T-observed tells me that the actual difference between how long they stared at the person who just sang them a song and what you'd expect to see just randomly due to chance, that actual difference is 2.9597 times larger than the difference you'd expect to see due to sampling error or just random fluke differences, just due to chance. We're still doing two-tailed tests, so we're just going to focus on this P and this T. This tells us, this p-value tells us, that the probability of getting this difference between how long they stared at the singer and how long you'd expect to see due to chance, the probability of that outcome happening due to sampling error is only 0.006. Or in other words, there is a 0.6% chance that you would have gotten this result due to sampling error. That's really low. So if we draw this out, kind of in the way that we're accustomed to doing it by hand, remember, half the alpha level is here, 0.025, half of it is here, we're really saying with an alpha level of 0.05 that our t-statistic has to fall in the extreme 5% of the sampling distribution to say, oh, probably wouldn't have got this just due to chance. Well, this falls in the extreme 0.5% of the distribution. It's way out here. So again, that tells us to reject the null. Our p-value of 0.006 is less than our alpha level of 0.05. Reject the null. We also know this because our t-critical of, on this end, 2.04, and on this end, negative 2.04. Well, now our actual t-statistic falls in that critical region. It's way out here. So that also tells us that we would reject the null hypothesis. Our t-statistic of 2.96 exceeds our t-crit of 2.04. Let's just reconfirm that we did this correctly. You can see that our t here now, right, is 2.96 with a p of 0.006. Check it out. 2.96, 0.006. Now you'll also see that they provide Cohen's d. So I'm going to show you how to do that in Excel as well. And you're going to be asked to provide Cohen's d and also evaluate the size of the effect for Cohen's d in your assignment. So the way that you can do Cohen's d is, remember, the formula for that is the mean for group, or the mean difference between the sample and the population, or in this case between the sample and chance, divided by the standard deviation. So to do that, we can just put d equals, so we know what we're about to do, equals left parenthesis your mean for how long they stared at the singer minus the chance mean, close it in a right parenthesis, divided by that standard deviation that we just did. Now you can, if you already have the standard deviation, you can click this. If you don't, you can just type in SQRT square root and click the variance. Close it in a right parenthesis, hit enter. Cohen's d is 0.523. Cohen's d is 0.52. Awesome. And you can look at the table that tells you the different sizes of the effects to determine if that's a small, medium, or large effect. I believe it's 0.2 for small, 0.5 for medium, and around 0.8 for large. So you can make that determination on your own to answer this question. All right, we're almost done. We're on our final analysis. Now, the researchers didn't only want to see, did they stare at the person who sang them the lullaby longer than 50% of their time, or due to chance? They also wanted to see, did they stare at that person longer than they did the first time that they saw them before they sang them that lullaby, or at baseline? So now we're going to do a paired samples t-test to see what we find out. So we're going to go back to the data right here. Now we're going to be comparing baseline to the test phase. So we're going to make sure data is selected up top, click on data analysis. We're going to go to t-test paired to sample for means, click OK. So now our variable 1 is going to be our test phase. So let's go ahead and highlight that. Okay. And our variable 2, make sure you click in this box for variable 2 range, is the baseline. So just highlight that. And make sure labels is selected, 0.05. Now we're going to change this new worksheet label to baseline versus test. Click OK. Remember, double click between A and B, double click between B and C, double click between C and D to make everything fit. And now we have our output. So we have our means for each. You can see here that the mean for the singer is higher than the mean for the person who that they looked at baseline. You know, after they saw them sing the lullaby, they stared at them longer than they did before they sang the lullaby to them. Here's our variance. This is really like a, the variance is the same for each. We look at our observations. There's 32 infants. Correlation, but we don't care about that right now. There's our degrees of freedom. Here's our t statistic. That's t observed. what that tells us is that the actual difference in time that they spent looking at the singer before and after they heard the familiar lullaby, that actual difference is 2.42 times larger than the difference you'd expect to see in the time they spent looking at the person who sang the familiar lullaby before and after hearing the familiar lullaby due to chance. So again, remember, the Tstat always tells you how much bigger the actual difference is compared to the difference you would expect to see just due to random chance. Yet again, we're going to focus on the p-values for the two-tailed test because that's what we're running. This p-value right here tells us that the probability that you would have gotten this mean difference in time spent staring at the singer before and after hearing the familiar lullaby, that probability is only 0.022. Or in other words, there's a 2.18% chance that you would have seen this result due to a fluke, due to random chance. Well, we're willing to accept a 5% chance of that to reject the null, right? That's our alpha level. This is less than that, so that's one way that we know that we would reject the null and say that we do have a significant difference here. So let's go ahead and draw our picture. Two-tailed test, splitting that alpha level. 0.025 here, 0.025 here. Remember, if this Tstat falls in the extreme 5%, we reject the null. Ours falls in the extreme 2.2-ish%, so we definitely are going to reject the null based on that. Also, if we sketch our t-crit, we've got 2.04 here, negative 2.04 here, and again, our t-statistic is out here. It falls in that rejection zone. It's extreme enough for us to be confident that we didn't get this result due to random chance. We got this result because the infant saw the person singing that lullaby, and now they're going to stare at them longer. So now let's just confirm our results against the journal article. You'll see here we did the t-test now. The mean of 0.072 is the mean difference. I'm going to show you how to get that in a second. I'm also going to show you how to get the standard deviation in D in a second. Keep in mind, these are not the same as this. Remember, when you do the math for this kind of t-test, you're going to take each person individually and take their different scores between baseline and when they watch the singer, right? After they heard the song. That's not what this is. This is the mean overall. This isn't the mean difference. So I'm going to show you how to get those in a minute. But you can confirm that the t-statistic is 2.42 and our p-value is 0.02. 2.42, 0.022. So now let me show you how to actually get that mean difference and that standard deviation of the mean difference and then Cohen's d. So if you go back to your data, and you're going to need to do this for your assignment, you will see that I already created this variable for you, difference in proportion looking. And the way that I got this was I took equals their score at test minus their score at baseline equals, and there you go. And you can just click and drag that down, and you're going to get all those numbers. I just want to show you where those came from. So now let me show you how to get the mean difference and then the standard deviation. So equals AV, double click average. Then just highlight all these different scores. Those are the D's that you would have calculated by hand, and hit enter. There's the mean difference, and let's just put mean difference right here so we know what it is. Here, let's put SD because that's what we're going to compute next, equals STD. Oh boy. Double click stdev.s because we're working with a sample. Highlight all those numbers. Hit enter. You've got your standard deviation. Now remember, Cohen's d is the mean difference divided by the standard deviation. So we go equals mean difference, the mean of all those different scores of baseline minus test, divided by the standard deviation of those different scores, 0.427, 0.43, that's rounded. That's how you get that. So that 0.427, you'd compare that to that chart. I believe, again, 0.2 is small, 0.5 is medium, 0.8-ish is large. So we would say this is a medium effect. So I've given you everything you need to complete your assignment, and hopefully also you feel like you've gotten some value out of this. You've learned how to do the analyses that you've been doing by hand by clicking a few buttons in Microsoft Excel. You also now know more than most people do about what these outputs actually tell you after you click those buttons. So congratulations, you should be proud of yourself.